Hi. So I have this little fairly inexpensive weather station. It's an Aercus brand. Oh wow, that was a kite, red kite. Did you see that? Um, yeah. So it's yeah fairly cheap as these things go. I think it's £150. This thing measures air temperature, pressure, sunlight, infrared, wind direction, wind speed, and this is a remote wireless unit, so it's battery powered, well, with a solar cell on it as well, solar panel on it rather as well, and that battery lasts over a year. And then I'll show you what's inside, which receives that data. Here we go. This little unit here with the blue LEDs on it is the receiver. So it receives the data wirelessly from the outdoor unit as well as from a little indoor unit as well. And then it's got an Ethernet socket on the back and it's connected into the network there, and I can pull data off it remotely. But the problem I have with it is that every now and then, every few weeks, it varies, it locks up. It gets into a situation where you can't communicate with it over the network. It doesn't respond to pings, ICMP pings, or indeed anything else. And the only thing you can do to fix it is come and unplug the power and plug it back in again. So I have raised support tickets with Aercus and with the British company that supports it in the UK, and I have got, I think, a couple of different versions of firmware, and neither of them have fixed the problem. So I just decided I was going to try and fix it a different way. So I wanted to come up with a little device which I've called the Rebooterator, which monitors this device via ICMP ping. So it pings it over the network, configurable, but at the moment every 3 seconds. And then if and the pings it sends have a 2-second timeout, so they're considered failed if they don't get a response within 2 seconds. Normally the response is within a few milliseconds. If 10 in a row fail, I think is how it's configured at the moment, then the power is cycled, i.e. it's switched off for a few seconds, then back on again. So here's the Rebooterator itself. So all it contains is a Raspberry Pi 0W, which is a tiny little Linux computer, a relay board, which is designed for use with Raspberry Pis and Arduinos and things like that, a few LEDs, a couple of switches, a few resistors. That's all there is to it. Oh, and a smoothing capacitor. So all that happens is 5-volt supply comes into the Rebooterator, which is the cable on the left, and then going out is another 5-volt cable with a USB socket on it, and that powers the weather receiver unit. So the 5-volt is also used to power the Raspberry Pi. So the LEDs on the front, the red one just shows that the program is running, and the green one, it's lit every time a ping packet is sent, and then it is extinguished when the ping packet is received. So if you see that the LED stays on longer, then that means that the ping's taking longer to respond. So the Raspberry Pi is connected to the network via wireless, whereas the weather station is connected via Ethernet. So I will show you a simulated fault by just unplugging the Ethernet on the little weather receiver unit. We'll just pull that out. It's coming around the front, and we'll see, right, those longer green LED on periods are showing that a ping's being sent and it's timing out after 2 seconds. So what we'll see is after 10 of those have failed, what the box actually does is checks it can ping something else, just to prove that the Rebooterator itself hasn't become disconnected from the network. And then if it can ping something else, then it recycles the power, and we'll see that in a few seconds. Just pan back a bit so we can see both boxes. You'll hear the clunk of the relay when it switches, and you'll see a red LED, I think it's red, come on inside the box. Neighbour's dog. Right, they've both gone out, so now it's pinging something else, and there we go. So what I'm going to do is quickly plug the Sorry about that. Plug the Ethernet back in. The power's still off, and now it's being switched back on again. I'm trying to remember what the intermittently flashing red and green means. Oh yeah, so basically it allows waits a configurable amount of time. I've set it, I think, to 90 seconds. After the power's been restored, or indeed when you turn it on from cold, where it doesn't monitor, because obviously it needs to give that little weather station a chance to boot up. So you can see not all the lights are on it yet. The second and third, so there you go, the third's just come on. That's saying that it's receiving something from the outdoor sensor, or set of sensors, the outdoor unit. And then in due course, within a minute or so, we'll see the indoor sensor light also go blue as soon as it receives something from that. So I'm not convinced I'm going to sit here and wait the full minute and a half. So anyway, I will continue the rest of this video with a description of how the circuit works and then of how the software works. So the Rebooterator has just a few components. It's quite simple to make. It's based on a Raspberry Pi Zero W. This is a tiny little computer. It's a fully functioning computer. You can plug a keyboard into it, a mouse, a monitor, and use it as, albeit a slow web browser. But you can do all kinds of things with it. I'm really underutilizing its potential here, I guess. But the reason I used a Raspberry Pi rather than something like an Arduino is that it's got a built-in IP stack. It runs Linux. I'm familiar with it. And they're really not particularly expensive. They're sort of £12, £15, something like that. On top of that, you need to buy a micro SD card to go in here, which holds the OS, a few pounds extra. It's powered by micro USB here. You can plug other devices in via this other micro USB port and a monitor in there if you need to. Although it is possible to get up and running even in a Wi-Fi environment without a monitor and a keyboard. You just need to edit a file on the flash drive to put your Wi-Fi SSID and password in. So the other thing that I'm using in the project is one of these relay units. Well, it's a relay coupled with the circuitry to drive it. So it's got two relays. In fact, I'm only using one of them just because I only had a 2 relay board lying around. So you can see it's got these little opto isolator chips on board, a pile of resistors and various things. There's MOSFET, which is used to actually switch the relay coil, and LEDs to show when it's being activated. So over here you supply 5 volts, ground, and then you've got 2 input pins for each relay. And you connect those pins low, i.e. you connect them to ground in order to switch the relay coil. So let's have a look at the circuit diagram. So I'm representing the Raspberry Pi here just by showing its GPIO pins. And then here's the opto-isolator and relay unit here. And then there's a few other components. We've got 3 LEDs. There's a white one, which is permanently on when the Raspberry Pi has power, whether it's booted or not, whether it's working or not. Then we've got a green LED controlled by software, a red LED controlled by software. And we've also got a couple of switches. There's a toggle switch here and a reboot/halt switch. So the toggle switch is basically so you can effectively disable the Rebooterator. In normal operation, you have the switch up, which is in auto position. And then if the Rebooterator cannot ping the device that it's monitoring, then it will power cycle it. However, if you set it in the on setting, it doesn't do the power cycle. It fills the log files with all the information. It behaves in every other way as it would do, but it just doesn't power cycle it. So if you know there's a problem with the device, or you're doing some maintenance or something, then you can just flick it to on and it will stop it power cycling. And then the reboot/halt switch, this is just there so that the downside, I guess, of using a Raspberry Pi, which is a full-blown Linux distro on it is that unlike an Arduino or a PIC or something like that, you really need to power it down cleanly. You can't, if you just pull the power, you'll get away with it most of the time, but every now and then you're going to cause a corruption to the file system or a problem of some kind. So you really should cleanly shut the OS down as if it was a Mac or a Windows box or something. And this switch just allows you to do it. If you hold this push button switch down for 5 seconds, then it either reboots or halts the Linux OS. And the decision as to where the reboot or to halt is actually the position of the toggle switch. So in auto mode, i.e. the switch up, then it will halt the OS, and in the down position, it will reboot it. So the input pins are all pulled up, by which I mean they are connected via a high value resistance, a pull-up resistor, to the positive supply, which in the case of Raspberry Pi is 3.3 volts, by internal resistors within the Raspberry Pi itself. I could have done this in circuitry. I'm not going to go into loads of detail, but basically when you're using input pins with this kind of device, you need to stop them floating, which means if you don't either tie them up or tie them down, the voltage of input pins tends to fluctuate, and it can cause weird things to happen, and it can make it look like switches have switched when they haven't. So you can do it either way. Convention is most people seem to pull them up, which means I've got this high value resistor effectively in the circuit, although not shown on this diagram, that is connecting this pin here to 3.3 volts. The other thing I've got with both of the inputs is series resistors, and the reason that they are there is just best practice. They're not, strictly speaking, necessary, but if by accident you set this pin here, GPIO18, as an output pin and set it high, i.e. to 3.3 volts, if there was no resistor here and this switch was closed in the right hand on position, then you would send a lot of current through that pin or out of that GPIO18 pin, and you could actually damage the Raspberry Pi. So it's a good idea to always put series resistors. Most people seem to use a kilo ohm for that. Then the LEDs themselves, they have series current limiting resistors. They're different values just because I wanted to get the resistors around about the same brightness, and so I had to joggle around with the resistor values to get them looking about the same. Okay, so the USB cable comes in here. The ground and the data pins, data lines, are just looped through. The data lines actually don't form any part of the circuit whatsoever. The ground we take a tap off, and the plus 5 volts input we also take a tap off. Got a smoothing capacitor there. I think it's 4,800 microfarads, so a smoothing / decoupling, and then that's wired to a micro USB plug which powers the Pi. You could power the Pi direct from the 5 volt pins here, but it's generally recommended that you don't, because you don't get the same degree of protection. I think you maybe miss a voltage regulator or certainly a polyfuse or something like that. I don't remember the detail. And then the output of 5 volts going towards the output cable here to a USB socket where the weather station unit is plugged. That goes through the normally closed contacts on the relay. So when this relay is not energized, those contacts are closed and the 5 volt flows through and gets to the device that we're monitoring. Only when we apply a voltage to the coil of the relay is it going to break that circuit and cut the power going out of USB out. Is there anything else to say here? Oh yeah, so we've got another output pin here which is driving this opto-isolator unit. So GPIO22, which is on pin 15, is connected directly to input 1 on the opto-isolator relay unit, and I think I already said you switch that to low, i.e. switch that to ground in order to switch the relay, which in our case will open these contacts and will power off the device we've got connected to the output. So let's have a quick look at the software. So this is a Python script, Python 3. I'd like to preface this by saying I'm not a programmer. It's just a hobby for me, and I'm sure that it's probably not the neatest or the best way of doing things, but it works for me. I'm not going to go through every line of this, but just mention some of the salient points about how the program works. So this program gets automatically run at boot time. In fact, it's being run by a shell script, which itself is a loop, so that if the Python script fails, the shell script will wait, I think it's 5 seconds, and then we'll try and run it again. So if something goes wrong with the Python script, it doesn't just die and stay died. So we import some libraries, then we set a load of variables. So reboot host is the device that we're actually monitoring. So in my case, this is the weather station receiver unit. And then, this is, I guess, an important point. Sanity host A and sanity host B. So these are two devices on my LAN that should always be up and responding to ping. And the reason these are important is just because the Rebooterator can't ping the weather station receiver doesn't necessarily mean there's a problem with the weather station receiver. It might be a problem with the Rebooterator's connection to the network. It's connected via Wi-Fi, something could go wrong. So basically, it will only power down or power cycle the weather station receiver if it cannot ping 10 pings in a row, and if it can ping at least one of the two sanity hosts. If it cannot ping the sanity host, it waits, and in fact goes around in a loop until it can ping one of them, and then it will check the reboot host again and only reboot it if it cannot ping it. So a few more variables. This is for that reboot reset button, the push switch. 5 seconds you have to hold it down to either reboot or power off. Then when you're doing the power cycle to the weather station receiver, how long you keep the power off, 10 seconds. Right, monitor delay is how long when you power the device up from cold, it waits before it starts monitoring the reboot host. Also, when it's power cycled the reboot host, it waits that amount of time before it starts monitoring again. Ping interval is the delay in seconds between pings, sends a single ping packet, waits 3 seconds, sends another one. And then this is how many pings to fail in a row before you decide that indeed the reboot host is down and it needs power cycling. This is assigning the various GPIO pins on the Raspberry Pi to their different functions. A log file, a switch debouncer. I'm not going to go into detail on that here. There's lots on the internet about debouncing switches. And then, as I mentioned, the toggle switch, depending on the position of that, if you hold down the reboot button, it gives you either a reboot or a halt. So that defines which commands should be called. So then we've got a few functions. One that sets up the logger. This is the function that does the OS halt or reboot for the Rebooterator itself. It's a bit ugly, this code. It's not really good. In fact, if you just press the button briefly and then waited 4 seconds, then held it down 1 second, it would reboot it. It's just kind of good enough because I don't really expect to be using that switch very often. I haven't bothered making it any better. Then this tiny function here, which is really just 2 lines, is actually what does the ping. So quick note on this. There is a library for Python called libping, which allows you to ping natively from Python. It means you have to run the Python script as root. I did play with it briefly, and then in the end I decided I was just going to use an OS callout. So actually it just shells out, uses the os/bin/ping command. C1 says send a single packet, W2 means timeout 2 seconds, S0 says send the smallest ping packet you can, the smallest legal ICMP ping, and then -N is don't resolve host names. I'm not sure that's really necessary here. Just a note here, if you wanted to monitor something in a different way from ICMP ping, like say you had a device that was flaky and when it broke, it still responded to ping, but it didn't respond to TCP connections on port 80, for example. You could replace this bin ping with an nmap command to say, see if port 80 is open. There's a number of things you could obviously replace that with. Right, the sanity ping is an endless loop that runs until either one of those sanity hosts, A or B, returns a single ping packet and then it exits the loop. Tiny little function which calls a shell script that sends an email. So the email is sent only if the device gets power cycled, the weather station receiver. Then we set up the pins. As I mentioned, we're using pull up resistors for both the toggle switch and the push switch. And then we're setting the output to be high, i.e. 3.2 volts on all three of the outputs, which is the power relay, the green LED, and the red LED. So remember, the power relay is not switched when the output is high. It is switched when the output is connected to low, to ground. And then here's a handler. It's an interrupt-based handler to detect the reboot/halt button has been pressed and go and run that function we just looked at. Sets up the logger. Then the first thing it does in the main program proper is the sanity ping. So when you powered up the Rebooterator from cold, the USB will be on. So it will also power up the device that you're monitoring. It will then go in a loop until it can ping at least one of those sanity hosts. And this was just a lazy way of me also checking that the Rebooterator itself has got an IP address, is connected to the network. Once it can ping one of those devices, we assume that all that stuff is good. Okay, so then here's the main loop, this while true loop here. So the first thing we do is wait for the reboot host, the device we're monitoring, to boot up. I've set that in the config to 90 seconds at the moment, and it just flashes the LEDs while it's doing that. So it flashes them intermittently, so green on, red off, and then vice versa. And then this is actually the meat and gravy of it. This is the core of the program. So most of the time, you're just going around this little bit of code here. So this is saying, while you haven't got 10 pings in a row, as we've configured it, then turn the green LED on, go and ping the reboot host, wait 0.05 of a second, which is just to make sure the green LED stays lit long enough that you can see it, and then turn the LED off, the green LED off. So if you don't get a 0 exit status code from that ICMP ping that the OS does, then you know there's a problem. So if it's a 0, it means you've got a response. Anything other than 0, we're taking as a failure, and you actually get different error codes depending whether the Rebooterator OS doesn't have an IP address itself, gives you one error code. If you get a timeout, you get a different error code, and you probably get a different error code still if you get something like an ICMP unreachable message from an upstream router, say, between the Rebooterator and the device that you're monitoring. So you basically, if you don't get a 0, then you add 1 to the failed ping count, and when the failed ping count gets to the max, hang on, where's the variable? Failed pings max. So once the failed ping count gets to failed pings max, then we do the power cycle. But you only need to get 1 ping back to reset that back to 0. You could make this more sophisticated, and you could say, you could alter the code to say, if I'm getting more than, 20% packet loss, then I also reboot. Depends on the device you're monitoring and the way it fails. My device is either working fine or it just completely fails responding to ping, and therefore I want to reboot it. And then, so this is an interesting one. And again, this was some sort of laziness on my part, really. So after the 10 pings have failed, before you do the power cycle, you do a sanity ping again. Which means you go and ping one of those or both of those IP addresses that should always be up, and as long as one of them responds, you do actually do the power cycle. The reason I've put this here is because imagine the scenario where actually the Rebooterator itself has lost its connection to the network. In that case, you don't want to power cycle the USB socket. So it does the sanity ping, and if let's say the Rebooterator itself is the device that's lost the connection to the network, and there's nothing wrong with the device you're monitoring at all, it will just sit in a loop until it gets its connection back again. And once it gets its connection back, then it goes and pings the reboot host one more time, the last ditch response. And that is just to cover off this corner case where the Rebooterator itself loses its connection. So if by the time the Rebooterator can ping at least one of the sanity hosts, the reboot host is also pingable, it will not power cycle it. But if the reboot host, in the kind of normal failure where the device that you're monitoring has failed, the sanity ping will prove that there's nothing wrong with the Rebooterator, and it'll do one last check of the reboot host itself. And if that fails, then it'll do the reboot. And then we've got the logic in here for whether the toggle switch is in the up or down position. So normal position is auto, which is up. And in that case, it will power cycle it, and it will send an email when it's done so, and obviously put something in the log file. If the switch is down or in the on position, it will do everything in terms of the logging, but it will just give you a different message saying would power off USB, but toggle switch is set to on. And then there's just a log there. So basically, we should never leave this loop. So if you get this far in the program, something's gone wrong. So just wanted to put something in the log in that case. Not that I've seen it here. So just going back to the diagram, obviously you could monitor, or you could rather switch multiple things. You can buy these units with up to 8 relays on them, I've seen, possibly even more. So you could set up a single Raspberry Pi to monitor and power cycle a number of devices if you wanted. You could even switch mains voltage with these contacts. They're rated to 250 volts, these relays. However, I don't think I would with these particular units. These are kind of cheap generic units, and they don't have any cutout in the PCB to give better separation between the low voltage and the high voltage side. So purely from a safety perspective, I'm not sure I would switch mains. Obviously, you could switch a different relay, which itself could switch the mains. And actually, I've got I think it is an 8 relay unit, the other one I've got, and that does have cutouts in the circuit board to give better separation between the low and the high voltage on that board, which would be a bit safer to use with mains voltage. So I think that's about it. Thank you for watching. If you've managed to get this far, you're very brave. If you find this useful and you use it and possibly modify it, make it a bit better, then I'd love to hear about that. So thank you very much indeed for watching.